Good. So let's take another case. Very interesting case. So there is this pulley. And it is connected with a block. Let's call it B. And another end of the string is connected to a bead. Okay. This bead can freely move up and down on this rod. Right?
Right.
Up and down. Okay. So the question is, if the speed of this bead, let's call it A, is 20 meter per second, we need to find the velocity of this block. Okay. And let's say if this block, this bead is going in this downward direction with VA velocity, that means this block is going upward, right, with some velocity. Yes or
Yes.
no? So this distance is fixed, right? Let's say this is x distance, then this would be L minus x distance. Yes or no?
Yes.
Okay. So we can make a triangle out of it, right? This is S distance. Let's say this, okay. This bead, I mean, goes downward with y distance, okay. It displaces y in downward direction. Yes or no?
Yes.
And this is L minus x, right? So again, using Pythagoras, we can say that L minus x whole square is equal to x square plus y square. Now remember that this y is basically over V, right?
Right.
Okay. So if you differentiate this thing, it would be minus dx by dt is equal to, the differentiation of this s square would be 0. The differentiation of this y square would be dy by dt. Okay. And this Vb is basically dx by dt. Alright, so we can cancel out these two and we'll end up with L minus x. This dx by dt is nothing but Vb, and this is y. And what is dy by dt? It is Va. And Va was given, right? It was 20 meter per second. And we are required to find this Vb. So Vb is basically 20y upon L minus x. Right? So this is our final expression. This is our final result. But let's say this angle was given. Let's say this string was making an angle 30 degree with the horizontal. So in that case, Vb would be minus 20y divided by L minus x. What is y divided by L minus x? See, y is our base, right? This is acute angle. Sorry, this is 30 degree, okay. So here, this is 30 degree angle. That means this is y, this y is adjacent side and this L minus x is hypotenuse. What is adjacent upon hypotenuse? It is cos theta, yes or no?
Yes.
So you can put here, instead of y divided by L minus x, you can plug that value of cos 30. And what is cos 30? Is it root 3 by 2, yes or no?
Yes.
So here our final speed would be 10 root 3. That is our answer. And why we are getting minus sign here? That means block is not going upward, rather it is going downward, okay? And here this bead is not going downward, it is going upward. So it represents
Right.
the its direction. Alright?
Mm-hmm.
So this concept is about constant relation of connected bodies. So let's say you are having a body of any random shape, okay? And let's say it is going with the velocity v0. So we know that every particle is going with velocity v0, right?
Right.
Okay, so if you draw a line here, and let's say for the moment, this particle is having a velocity va, and this particle b is having a velocity vb. So it is making an angle theta with this connecting line, right? So you can write this the component of this va in this direction as va cos theta, yes or no?
Yes.
And this would be vb cos theta, alright?
Right.
Let's say the distance between both these particles is L. So since this is a rigid body, so relative velocity between A and B would be what? 0, yes or no? Along this AB line, yes or no?
Long AB. Oh, yes. Okay.
First of all, there it's a rigid body, right? They
Mm-hmm.
are moving with velocity v0 in x direction. And if
Right.
you take its component in this y direction along this line joining both the particles, and their velocities would be va cos theta and vb cos theta. So since it's a connected body, the relative velocity between both these particles should be 0. That means va cos theta must be equal to vb cos theta. Yes or no?
Yes.
So that is what important here. Okay, so let's see how we can apply this concept. Okay. So we'll solve a one. We are gonna solve a question with two methods. Okay. Let's call this method D2 method. Okay. All right. So let's say we are having a rod of length L. This is the situation of this rod. Okay. So first of all, we'll go with D1 method. Okay. Then we will discuss this D2 method. So let's say this is end A and this is end B. All right.
All right.
Good. Let's say this end goes downward with velocity va. It is making an angle theta, and this end is going with velocity vb. And we are interested to find the relation between va and this vb, right? Yes or no?
Yes.
Okay. So how we are gonna find this relation? We did this question earlier also. Yes or no?
Yes.
So let's say this end displaces x in x direction, and this end displaces y in y direction. So we can make this triangle x and y. This is theta. So that means y by x is tan theta, yes or no?
Yes.
And the differentiation of this y is basically VA. So VA by this VB is basically our tan theta.
Right.
Or you can say VB is equal to VA cot theta, yes or no?
Mm-hmm.
So this is the final result and this is the answer. This is the relation between the velocity of point A and point B, right? This is according to D1 method. Now let's apply this method, okay, D2 method, to this same question and see how important and how easy it is, okay. So we know that this is going with velocity VB in x direction and this is going with velocity VA in downward direction. This is angle theta. If this is angle theta, then this angle would be theta, right?
Yes.
So that means the component of VA here it would be VA cos theta, and here in this direction it would be VA sin theta. Yes or no?
Yes.
Okay. Now if this angle is theta, that means this angle also
It's
theta.
theta.
That means this is VB cos theta.
Cos
Yes or no?
theta. Yes.
And according to this theory, along the line velocities should be equal, right?
Right.
That means VA sin theta should be equal to
V cos theta.
VB cos theta. That means VA is VB cot theta. See?
Okay. Right.
So this was demanding some geometrical approach, but this is pure physics, right?
Yes.
So this is the difference. There is another method also that is called D3 method. We are just naming it, okay, randomly.
Mm-hmm.
But we will discuss it later, okay. Right now, I hope you understood this very well. Alright?
Okay.
Okay, so you can use this approach in this question also. See, our first question. Okay, use that D2 method in this question. Okay, that is your homework. All right,
Oh. Mm-hmm.
or should I do it right now?
It's probably better if I try doing it on my own. I'll let you know how that goes.
As your wish. Now, what about this question? In this question also we can apply D2 method.
Okay.
Okay, so let me apply it. Okay, you know how I solved this question, right?
Yes.
Using taking this length and deriving this thing. Okay, now let's take this same question and apply this D2 approach. Okay, this is going with velocity VA. This is angle theta. This is VB. So that means this angle is theta, right? This is VA, which means that this is VA cos theta. Yes or no?
Yes.
This is the velocity of the string, right? Which is in this direction. Velocity of block. And whatever the velocity of block is, that is the velocity of this string in this direction. Yes or no?
Mm-hmm. Yeah.
Okay, so here VB is equal to VA cos theta. That is our answer. Easy?
Oh. Yeah.
See,
That's simple.
see, same question. See, we derived this thing. See here, VB is equal to this minus 20 was VA. See, same result. But see how this method was quick. Yes or no?
Yes.
So it's a really beneficial method.
Mm.
Okay. So let's take another example. This example looks very scary, but actually it's not. Okay. See, there is this pulley and it is connected with two bodies this way. This is a pulley, okay. And let's say the angle between horizontal and this string in both these cases is alpha and beta. And let's say both these blocks are moving with different velocities, okay. Let's say this is going with VB velocity. So how we are gonna find relation between VA and VB, huh? If you are moving this block in this direction, that means this block also moves in this direction. Yes or no?
Yes.
Okay, so how we can find the relation? If this is VA, then that means this is VA cos alpha. And if this is VB, that means this is VB.
VB cos beta.
Since the string is same, that means the velocity remains same, right?
So both of them are equal.
Yes.
Okay. V is V plus V.
That is the answer.
Oh, okay.
Pretty easy, right?
Yeah.
Good. So this was the approach for connected bodies, okay. So I think now you have learned everything about how to proceed for connected bodies, the constraint relation, how to find constraint relation. Yes or no?
Yes.
Very good. Now let's talk about pulley and block system, okay. How to solve pulley question. Let's call it D1 method, okay, for simplicity. Because
Okay.
there are three methods, okay, three or four methods. Let's say this pulley is connected with two blocks A and B. If this block displaces X in upward direction, that means this block displaces Y in downward direction, right? Let's say here the velocity of this block is A, here its velocity is VB. Since they are connected with the same string, that means the velocity, here the displacement will be equal, right? And if you differentiate it, you will end up with their velocities. And if you again differentiate it, you will end up with their accelerations.
Acceleration.
Very good. Now let's make it a bit difficult, okay? There is this pulley, block A, solve this question. Okay, so how we are gonna solve this question? See, let's say this block A displaces by an amount x in upward direction. So since this string is only one, okay, That means it will transfer x displacement in this downward direction, right? And here this
Yes.
pulley is connected with two ends, right? This one and this one.
So it'd be
this
2x.
yes. So here whatever the y displacement was, it will be equal to 2x. Okay. This is the property that if a pulley is connected with two ends, let's say this gives us x displacement, this gives us y again x displacement. That means the resultant displacement of this pulley would be 2 times x. This is the property of a pulley. Okay.
Okay.
So here y would be equal to 2x. If you differentiate it, it would be VA is equal to 2VB. And again, if you differentiate it, you will end up with 2A.
Or would it be minus VB?
Right now we are
No?
just ignoring the signs. Okay.
Okay.
Yes. Now comes a pretty difficult question. An important too. Okay. This is block A. It is connected with another block via a pulley. This pulley is connected with this pulley. Pardon my diagram. Okay. So let's say this block displaces x in upward direction. So it will transfer x displacement downward, right?
Mm-hmm.
So that means, and if this goes x in upward direction, that means this pulley will go down by x, right? This x is getting transferred to this pulley, right? So this pulley will move downward with x displacement. Yes or no?
Yes.
Okay. So this x, and this x. Basically
Equals
this x.
3x.
So the resultant displacement of this block would be AY would be 3A. Alright?
Okay. So it's just adding every length of the
Yes.
rope.
Yes.
Okay.
Pretty easy, right?
Yes.
Another question. This looks difficult, but it is the simplest question. Okay. You wanna try this one or what?
And so I'm assuming that block C goes upwards. Or
Okay. Let's say it goes upward by an amount Z.
okay. So would B be 3Z going distance?
Let me do it. Okay.
Okay.
See, let's say this displaces by an amount X. This displaces by an amount Y.
Okay.
Okay. So this pulley is displaces by an amount X. Okay. So that means here the displacement would be 2x, right? Total displacement, this x and this x, right?
Right.
Same way, this y and this y. So it would be 2y. So z is equal to 2x plus 2y, yes or no?
Yes.
So that's it. Just differentiate it. These are the relations. Understood?
Oh, okay.
So
Yes.
there are shortcuts as well. Okay, that that is called D2 method. Okay, we will again solve all these questions using D2 method. Okay, that is way
All
more
right.
simpler than this one. Okay,
Mm.
but before that, let's take a humongous question. Okay,
All
difficult
right.
question. Are you enjoying these questions or not?
Yeah, these ones are more interesting.
Good. There is another pulley and it is connected with block C. This is connected with block B and this pulley is connected with block A. Now here we need to find the constraint relation, the relation between velocities of different blocks. So tell me how we are gonna find it. So let me do it, okay? Let's see. Let's say this
Okay.
block A displaces x in upward direction. That means this pulley displaces upward x in both the direction for both these ends, right?
Yes.
So since this end is connected with the roof, it cannot move. That means 2x displacement will be transferred to this string in this direction, right? And
Right.
eventually it will transform to this pulley, yes or no?
Yes.
So both these ends will transfer 2x displacement
X.
in downward direction. And let's say this block y displaces by an amount y. And this is C displaces by an amount z. Alright?
Okay.
So we can write this y as how much total displacement it is having. This 2x
2x plus the
plus this
other
2x,
2x.
okay? So that is 4x plus
Yes.
this z displacement, right? Which is in upward direction.
Right.
You can differentiate it. 4va plus vc. That is our answer. So there are
Okay.
D2 and D3 methods to solve this question very easily, okay? Still it looks a bit messy, okay? But we'll use D2 and D3 method to solve this question. So right.
All right. Yeah.
So that method is called work tension method, okay?
Mhm.
This is our D2 method. So first of all, let's understand what is tension. So tension acts at all contact points of string away from point of contact, okay? It acts at all contact points of spring away from the point of contact. Alright?
Right.
So for example, let's say we are hanging this block. So here at this point, uh, tension acts in downward direction. But at this point, tension acts in upward direction. That's why this definition that it acts at all contact point of spring away from point of contact. Understood?
Yes.
So there are some pre-assumptions. Okay. So what are these pre-assumptions? So we are gonna consider massless and frictionless springs. Okay. We consider tension force T remains constant for full length of string. Alright?
Right.
And for massless pulleys, you know that for massless bodies, net sum of all the forces is zero, right?
Right.
Why? Because F is equal to ma. If mass is zero, that means it doesn't matter how many forces you are applying. Force is zero.
Right.
So I think that's it for today, okay?
Okay.
So we'll meet again